Okay, hello everyone. Thank you for joining. Today I will be going over my project on how altitude impacts pitching characteristics, especially at Coors Field here in downtown Denver, which of course is the highest elevation ballpark in the MLB, and by a large margin. It's over 5,200, and the next park is 1,100, and then they go down from there. So the difference is there, and so pitch movement was appealing. So we came up with some research questions like how does course field affect pitch movement, both horizontal and vertical? Do pitches throw differently? Does the altitude lead to more hard hitting balls? Can we predict a model to quantify the effect of altitude on pitch movement? So everybody says that Coors Field is one of the more hitter-friendly ballpark, and so our goal is just to analyze pitching here at Coors versus um, non-Coors stadiums, right? So the other ones, and determine to see if the altitude impact can be quantified. Um, so we start with the libraries and Statcast. We're going to be using Statcast for this project. I personally have truly come to enjoy Statcast. So this worked perfectly. We did 6 years, 18 to 23. Um, and we got the pitching data. From here is where we really start thinking and what approach we were going to do here. And so after getting the data, what I decided to do was to create a CSV where I isolate only games played at court fields where they were the home team. So um, then, so this only select pitches thrown at Coors Field. Excuse me. Then we, that's right here. Then we identify pitchers who have pitched at Coors. So we extract all the unique pitchers. Because now we know this was, Coors, here down in at the Rockies home. So all those pitches were pitched here. So um, now we take their names, right? We took their ID so we could see who has pitched here um, from the smaller data set, right? So then we we're filtering the main data set for these pitchers now. So the point was that I wanted to be safe. So then we went back to the main data set, and we filtered to make sure that all the pitchers have pitched properly. So we retrieve the data for the same pitchers but outside of Coors Field. So this ensures that we compare the same players but in different environments, right? Isolating the altitude, right? So then we create the another CSV, the non-course pitching filter. Okay, so now we do some little analysis like checking for NAs, um, and just good habits, and then we get into the EDA more. So we do that, and then we start to get here. Um, so the pitching summary. So we start with the pitching summary, and this is this is just the descriptive statistics on release speed, spin rate, things like that, so we can compare the locations. And the results were that pitch velocity is slightly higher here in Coors Field. Spin rate is lower at Coors. Vertical movement is lower at Coors. And horizontal movement is also reduced, meaning like breaking pitches don't move as much side to side. Um, For number 3, the vertical movement, that means that pitches don't, they drop less. So everything that's making batting easier so far. So that was the result of that. Then we move to what I have in my notes at step 2. Now that we're here in this section, which is categorizing pitches into groups. This was to better visualize trends. We group pitches into fastball, breaking balls, and changeup. So then we go into visualizing vertical movement first. We did box plots to compare the vertical movement of pitches here versus other stadiums. Boom, boom, boom. And then these are the box plots, as you can see, vertical movement at Coors, the 3 types of pitches. The result is that breaking balls, so sliders and curveballs, show significantly less drop here at Coors, meaning that they stay higher in the zone than expected. Fastballs at Coors have slightly less vertical drop. Changeup also drop less at Coors, making them potentially easier to hit. So one of my takeaways from here was that altitude does affect pitch movement, particularly in breaking balls. So then we move to the horizontal pitch movement, as you'll see in this code. And the results here were that so at Coors, fastballs show less horizontal breaking balls have reduced movement compared to other stadiums, and changeups display slightly more variation in horizontal break. So we'll have to speed up a little bit. So conclusion is that movement is significantly reduced, particularly for breaking pitches. So thinner air reduces resistance, causing less lateral movement. So far, that's showing to be true. So then we move to our next conclusion here with our we're comparing the mean and standard deviation of movements, and our result is that horizontal movement is reduced and vertical movement is also lower at Coors, and then breaking balls suffer the most. So then I wanted to check the data set and print to confirm that my filtering worked, among other ways. We did that. Then we moved down to double checking that as well. Yep. And finally, we get to section 3 here, comparing pitch by distributions, and the plots over here, pitch type by distributions. And so our conclusions were that fastballs are thrown more often at Coors Field, breaking pitches are thrown slightly less at Coors, and fewer changes on splitters at Coors compared to non-Coors stadiums. So pitchers increase their fastball usage while reducing reliance on breaking balls. And then this makes sense because breaking pitches are less affected at altitude. So then we go into whiff percentage, computing whiff and identifying whether breaking balls or other pitches are less effective. And so Our result is that breaking balls are significantly less effective at Coors, which matches the whole altitude theory. Um, so then fastball actually performs slightly better at Coors, because of probably the higher velocity at high altitude. Um, then then we I wrote some code because I was having an issue, and it's because I forgot I removed the column. So I figured it out, then I re-added that column so that we can continue with our data set. That was what happened with the description column. So then we moved on from there, and it was the strike rate and the hard hit rate that was next. So that's over here. Our results. So our results here is that strike percentage is generally lower at non-Coors stadiums. Fastball has higher strike percentage at Coors compared to other stadiums, and breaking balls do not show a significant difference. So this suggests that like altitude does not impact strike rate as much as movement, and so we then continue to our heart rate percentages here. So Coors has a higher heart hit rate compared to non-Coors stadiums. So this confirms the theory that thinner air does result in harder hit balls. So it has to probably do with extra velocity. Lower air resistance probably increases that. Not a major difference, but it does support the theory. Okay, and then from there, we are now going to move forward to spin rate distribution analysis. So it's comparing the spin rate, and that is right here. And our result is that no significant difference in spin rate distribution. So there wasn't much there. Breaking ball effectiveness loss at Coors likely due to reduced Magnus effect. So there was that from that analysis. Then we moved into our pitch usage difference at Coors versus other stadiums. And our results were that fastballs are thrown more frequently at Coors. Breaking balls have lower usage. Sinkers and cutters remain relatively stable between the two. So increased fastball usage is one of the main difference. And then breaking balls are used less, which makes sense as they rely on movement. So then we move on to our next, which is pitch velocity differences. This was the chart. And now we're here. And for this one, we average pitch velocity. Almost all pitch types have slightly higher velocity at Coors. So the lower air resistance at Coors results in slight higher velocity. So then from here we did a XGBoost to predict regression to predict the horizontal and vertical movements. So our conclusion was that we built it to predict the movement based on altitude, it captures effectively the relationship between the two. It does play a major role, and then we also we train the model, we do all this stuff, we plot the importance of movement, and so we created the graphs, and the result is that the most influential feature is acceleration in the x direction. Altitude has little impact on horizontal movement. So final conclusion is that the altitude does reduce air resistance, leading to flatter breaking balls. Fastballs and breaking balls show less drop. Horizontal movement is not affected. Unlike vertical break, horizontal break is mostly determined by spin direction and velocity, not altitude. Final thoughts would be, since I ran out of time, our analysis confirmed that Coors Field has a clear impact on pitching performance. Pitcher must adjust their strategy when playing in Denver by throwing fewer breaking balls, relying more on location and velocity, understanding that vertical movement is reduced, making pitches easier to hit. Thank you.